Hello and welcome, dear viewers, to another episode of What's New in Prisma. I'm here today with my colleague Daniel again. Daniel, it's nice to see you today. How are you doing?
Yeah, very well. I've been actually cooking a stew, and now I'm here for this live stream. So super excited. We've got a lot of cool stuff.
Indeed, we have so much that we want to cover today. In fact, we'll have 3 guests on. I think this might be a record for this show, actually. Like maybe not considering the holiday special that we did last or 2 years ago, actually. But yeah, it's super interesting. We'll talk a little bit about the latest release that happened on Tuesday, where we introduced a ton of new features, among them major improvements to Prisma Migrate, then a preview release for CockroachDB, where we'll also have a developer advocate from CockroachDB on the stream today. And then we'll talk about authorization with Cerbos, and as well have somebody on who is going to demo that for us. So that's really exciting.
Yes.
Should we jump right into Tuesday's release and just walk over the release notes as we usually do it here on the stream?
Let's do it.
All right, I'm going to go ahead and share my screen for that. Share the screen. I think this is the one. And this is the Prisma repo that I think you can now see. And by the way, one thing to note about our repository, one thing that happened this week and that we celebrated on Twitter is that we finally reached the 20,000 stars on GitHub. And that's a friendly reminder that if you haven't started our repository yet, but you're using Prisma, then maybe consider leaving us a star as well and help us getting to 30,000 stars. All right, let's look at the latest release, 3.0 actually. 3.1 was a patch where we fixed an issue that came up, a small regression. But the 3.9 release is what happened on Tuesday. So let's quickly skim over the release notes before we then dive into the details with the folks that we have as guests today. So first of all, we have 2 new commands for Prisma Migrate. And this is basically a reaction to the common concern that developers have when they're using Prisma Migrate, that they have difficulties handling failed migration. So when a migration that you execute against the database fails for some reason. So for example, because you're like violating any constraint that you have previously defined on the database, then the migration fails. And it wasn't too straightforward to deal with these kinds of scenarios in Prisma Migrate before. And a workflow that's commonly used by other migration tools is the idea of down migrations or rollbacks. And developers often wondered how they could achieve similar things with Prisma. And I think that the 2 commands that we introduced here on Tuesday and that are going to be demoed in just a bit actually will help quite a bit resolving these kinds of troublesome migration scenarios and help developers get a clear understanding of what is happening to their database schemas.
Yeah.
Then, as quickly mentioned, we also broaden the support for the databases that you can use with Prisma. So we now support CockroachDB in preview. And it's an interesting situation with Cockroach because some people have been using it already, because I think it pretty much uses a similar SQL dialect as Postgres. You can correct me if I'm wrong here. So people have been trying it out with Prisma already, and it works for quite a few use cases already, or it used to work for quite a few use cases already, but there always were some subtle issues because, of course, Cockroach is not identical to Postgres, and that's why we decided to build a dedicated connector for CockroachDB as well that we are releasing in preview now. And then we also make substantial progress with the implementation of the MongoDB connector. And I know that a lot of people are waiting for that. So that's always great news to share with everyone. And this week, we released a raw query support for MongoDB with new commands that you can execute, or new kinds of queries that you can execute with Prisma Client. So we've got this find raw, this aggregate raw, and run command raw that then allow you to pretty much directly tap into the MongoDB API and use the primitives that are provided by MongoDB for your Prisma Client queries. And the implementation of interactive transactions is also moving forward. So we fixed some issues there, and hopefully we can release it out of preview soon. All right, I think that's it for the overview of the new features from Tuesday's release. And I think with that, we can probably already start to pull up our first guest. And that would be one of the engineers on our team that's working on Prisma Migrate, and that's Matthias.
Yeah, so Matthias is actually one of Prisma's first engineers, and he's a Rust developer on the Migrate team. And interestingly, I think he's... Oh, hey, Matthias. Good to see you. So if you don't mind, I'll give you the full introduction, because I think it's kind of interesting. So you have started your path with a degree in business. You worked as a consultant. Then you got another degree in North American studies. And during that time, you basically quit, and then you pursued a third degree in computer science. And you've been with Prisma now for 5 years. You were already there when it was still called GraphCool.
Yeah, that's true. It's my first tech job.
Straight out of university, basically, right?
Yeah.
Nice.
And today we're going to talk about these two new commands, and you're going to show us some of the use cases for them and how they can sort of be combined and used. And they're quite versatile, especially this diff command. You can do a lot of different things with it. Do you want to share your screen, or do you want to maybe talk about it before?
Yeah, I'll start sharing, but maybe give some more background on the two new commands. So far, Migrate and Introspection, the commands we were exposing were envisioning certain workflows, and these were designed to help people in most situations, right? But of course, you run into situations where you hit an edge case, you hit a failed migration, and then these workflows become too strict for you to continue. And this is something that we've heard from our users, something we've understood. And this is why we started breaking down the commands and exposing the building blocks they are based on. And db execute and migrate diff are the first of these primitives that we're now exposing. And especially migrate diff, I think, is going to prove super valuable to the community. I'm going to demo one use case, but we are sure users will come up with many more use cases. And to go into what exactly these commands do, so migrate diff allows you to see the difference between two database schema representations. And with representations, I mean the source could be a live database, it could be a Prisma data model, or it could be a migrations history. And the command allows you to create a summary or a SQL script that describes what it would take to go from the first one to the second one. So similar to git diff. And this command is already powering migrate workflows, but we're now exposing it standalone to users. And db execute is a companion command. What it does is it allows you to execute SQL against a target database without interacting with the migrations table in that database. So you can use it to apply the script that diff produces, for example, and it won't touch the migrations history table. It will just apply it.
Right.
Yeah, super nice. And I also just dropped a link in the comments to the blog post that you wrote, Daniel. And there is also a really nice kind of like visual explanation of what these commands actually do. So I would recommend everyone to also check out that blog post if you want to have a bit more of a visual understanding of the flow of these two new commands.
Yeah, I would also recommend that. The graphics or the visuals really help with understanding the from to, which all sounds very abstract, but if you see it in the visual, then it becomes clear to you.
All right, Matthias, do you want to jump into the demo?
Yeah, sure. So you can see my VS Code here.
Yes.
And as you can see, I have a very simple data model here. It currently only contains a user. And let's say this is my state on my prod environment and also on my dev environment. I just started working on a new feature. I checked out the state of the database, and now I'm adding properties. So I'm making the name unique, and I'm also adding a second model post. My feature that I'm working on requires this, and what I would then do is I just just create a new migration with Prisma Migrate Dev, and I call it unique.
And Migrate Dev, essentially at this step, it actually uses under the hood the diff in order to figure out what's the difference between the from being the Prisma data model and the live schema.
The from
the migration
being
history.
the live schema and the to being the Prisma data model.
Right.
Because the resulting migration will add the unique constraints and the post. So take you from to. Yeah, and this is what I did here. And you can see you get a nice warning that you're adding a unique constraint and that this would fail if you have duplicates in your data. So we accept that, confirm, and we create a migration locally. Oh, I'm still on a dev version. I didn't use npx. Okay, that shouldn't matter. Okay, so now we applied it to our local database that now has the additional model and the unique constraint. And if we now want to migrate deploy,
this would be against the production database.
Exactly, yeah. So for that, I'm just gonna change out my env and my schema now points as at my production database, and I'm now trying to deploy this. And we get an error. And that is something that can happen in a lot of cases. So this is what a failed migration would look like. So in this case, we try to apply the same migration that ran successfully locally to our production database, but it failed. And we also get the error. It's what Migrate was already warning about, that if you have non-unique data in the column you are making unique, you will get an error when trying to apply that migration.
So like this would be a typical scenario where folks would now use a rollback or a down migration in production to kind of like roll this back and then really investigate what happened, right?
Yes, with the problem being that the migration did not only contain the addition of the unique constraint, but also created the post. And if you pre-create the down migration, it would basically try to delete the unique constraint and the post, but the unique constraint was not successfully created. Your migration failed halfway through. So any pre-generated down migration that contains all the steps kind of assumes that all the steps ran successfully. So it wouldn't successfully run in this case. And
Matthias, could you maybe, sorry to cut you off, could you maybe show us the migration, the second migration that we just created, the unique one? Just I think it would give folks a really good idea of what the reverse would look. So you were talking about this rollback or down migration, and this down migration, as you sort of pointed out, is written at the same time that you write this up migration.
Usually,
so what you were saying is that if you try to reverse these steps, is that reversing them would also fail because not all of them have been carried out.
Yes, it depends how you write your SQL, right? Of course, there are clauses like if exists or if not exists that let you hedge against this. But if you just do the naive approach of saying, okay, this is my up migration, contains a create table and a create unique index. So my down migration needs to drop that table and drop that index. Then it would fail because that index is not present. The creation of that index failed.
Right.
That sounds like a lot of headache and time-consuming debugging work.
Yes, and so far we didn't offer a Prisma tool that allowed you to pinpoint what exactly is the state of one environment or one schema description vis-a-vis another one. And this is what diff allows you to do.
Right.
So what I would now do in this scenario, I would run migrate diff, and it's a preview feature. That's why we still have to add the preview feature flag. And it takes two parameters here, the from, which in this case is the URL of our production database, and the to, which here is the data model defined in your schema.prisma file. And so the output would be what is missing to take my production database to the target state that I have defined in my schema.prisma. Yeah, and it tells us, okay, what's missing is a unique index on the user table.
That means that it was successful creating the post table, right?
Exactly. You now know what succeeded as part of your migration and what failed. And yeah. And since we know that the unique index is missing and we also know we have duplicate data, we now have the decision how to proceed, right? Because fundamentally there are two things you can now do. You can go forward. You try to apply the unique property. And yeah, if that makes sense in your business case, or you realize, it's actually valid to have non-unique data there, then you might want to roll back and start again with your feature and with your new understanding of your business case. But let's say in this scenario, we want to go forward. We realize, okay, that's just a mistake. There should not be duplicate data in our environment, in our production database. So what you can do is we can launch Prisma Studio, pointing it at our production database. And what you see here is we are on
If you can zoom in a little bit, Matthias.
Yeah, sure. We are on our only collection user, and we see, okay, we have actually two users that have the same name. And what you can now do is we modify that name. Let's call him Paul B. And save that. And now we've alleviated the fundamental problem, right? There is no non-unique data in our database anymore. But we're still left with the situation that we have a failed migration on our production database that will prevent us from running migrate deploy. We could not run the same migration again because the migration also creates a post table, right, that is already there. So we need a different migration to apply. And we can basically do what we did just now, but instead of getting a summary, what it would take to go from the current production state to the state in our data model, we can say we want a script that does exactly that. And we are going to store that output in a file.
I think there was a new line there.
Yeah, I saw that. Okay, so now let's have a look at that file. And yeah, so this contains exactly what's needed to proceed. You do not have to persist this in a file. We also support just piping it into db execute, which we will use in the next step to execute this against our production database. But if you prefer, you can persist this. This is not necessary, though. It does not need to become part of your migrations history. You can delete this file or never create it in the first place. But what we are now going to do is we are going to apply this to our production database, and as source of this command, we're taking the file that we just created. So this is now going to be applied to our production database. Okay, and it ran successfully. So what we now have is that our production database, our local database, and our migrations history, and the Prisma schema, the Prisma data model, are all in the same state. There's only one final step missing, and that is that on the production database, the migrations table persists the migrations that you ran and whether they ran successfully or not. And currently, that is still showing that the last migration failed. So we need to let Prisma know and let Prisma persist that in that table that that failed migration was actually fixed by us. And how we do that is we use an existing command, Prisma migrate resolve, which lets you choose how to deal with failed migrations. So you can either say that they were applied or that they were rolled back. And in this case, since we went forward, we applied it manually to get to the desired target state. We just let Prisma know, okay, the migration with that name was successfully applied. Okay. And it lets us know, okay, on our target database, that migration was marked as applied now. And if we now do Prisma migrate deploy,
I think, yeah, Prisma is missing.
Nice.
I think it's just Prisma is missing.
Yeah, okay. Well, so what it ideally would tell us now is that there's nothing to deploy. The environments are in sync.
You mistyped, Matthias. It would have been like npx Prisma migrate deploy instead of npx migrate deploy.
Okay.
So you only forget the
Okay.
Prisma command. It's all good.
Let's see. Okay. So it let you know there are 2 local migrations, and both of those are applied. There's nothing pending. And it also lets you know that there is no lock anymore to deploy to production with Prisma.
So that means that Prisma migrate actually, when you run this migrate deploy command and you have an unresolved migration that failed, it will actually not allow you. If you've already created new migrations, it won't
Yes,
allow
it would
you,
let
right?
you
It will
know
block
that there are failed migrations that you should address beforehand, fix beforehand somehow, either roll them back or roll forward. Because we do not want to keep building on an inconsistent state, right? If one migration failed, we are not sure what the state of your production database is. So we cannot guarantee that any further migrations that were created from a potentially different state will not just keep on failing.
So when you say that the migration could also be like rolled back, but in that scenario, the developer would have to write the SQL to reverse the like the actions themselves, right? Or is there also
No.
like any help?
No, that's the beauty of Prisma migrate diff, right? You can just turn it around So let's say we are in the stage at the beginning where we partially applied the migration. So the post is there on production, and your local database and your local data model assume that the unique is there and the post is there. So if you want to go back, what you can do is you get a hold of so there are several things you could do. So one of them would be you get a hold of the data model of your production database. So that's presumably the one on master. That would be the state before you made changes to your local data model. And then you create a diff from the production database to that data model. That would be a custom down migration for you from exactly where your failed database is to where you want to go. And another option would be locally you delete your latest migration, the one that failed, and then you say you want to go from your prod database to that migration history without the last one. That should be identical to the data model at that point in time.
Yeah, I really love the flexibility there that you get by effectively swapping out what you provide for the from and to options when you run the command, right? Because that really allows you to run the migration then in any direction. And so it's basically the way how I understand it, an even better way of doing down migrations, because you don't have to declare the down migrations initially, but rather like if you need them, then you can get them customized just for your particular schema, which is super nice.
Yeah, exactly. And what I think is also important to mention is that we are now describing a use case for diff and execute around failed migrations. But the command is so flexible, I'm sure people can come up with other use cases, right? Like you do not need to only use that in the case of failed migrations. You could also diff completely different environments just because you want to see the difference between them, right?
Yeah, it's a really powerful and kind of generic tool, actually. So super helpful.
Yeah, I mean, even like switching between branches and, you're like merging a pull request and now you want to check, is this new migration history? Does that reflect what my current database is, which I expect it to?
Yeah. One other use case that we've seen or envisioned is if you want to squash your migration history, right? If you realize there is no value anymore to having it in 15 separate steps, but you want it all compressed into one, then you could also just do a diff from an empty database to your migration history. And then it would basically spit out one migration that takes you from 0 to the final state of your history. Right. Like if you have a lot of experimentation in your migration history and you do not want intermediate tables being created and dropped that you had during development that are not needed anymore, then you could, for example, just do that.
That's very cool. Great. We're now going to do probably a Q&A. So this is a good moment if you've been watching us so far. Drop your questions in the chat. And I think just because this is a point that often comes up, it's worth sort of diving into as we wait for some more questions from the audience is, what about atomic schema migrations? So why not just wrap schema migrations in begin and then commit at the end, and then you're confident that either everything went through or nothing? You don't have this weird situation where the unique index hasn't been created, but the post table has, as we had in our case.
Yeah. So maybe you could see it from my data model, but I'm running on MySQL, and MySQL, for example, doesn't allow DDL wrapped in transactions. So here that option would not be there. And on databases that allow it, it also comes with extra costs, right? You might be locking down tables for a long time while your transactions run.
And when a table is locked, that means that no other request can actually be processed. So if you're doing a write to the table, it can't be written. So you'll
it depends on the kind of lock. There are different kinds of locks, and some are table locks, some are row locks, some are read write. But yeah, fundamentally, it comes with a extra cost, and it's not always possible to do.
Right. Yeah. Yeah, I think let's see if we still have any questions yet. So, okay, so I want to share a little anecdote on this. So I read an article about someone who basically he couldn't wrap his schema migration, which was adding like, I think a unique constraint, or it was adding an index, and he couldn't wrap it in a transaction. So he basically started running it, and the table in production had over, I think, 5 billion rows, and it was causing a table lock for the whole period. So no writes could go through. And anyways, it was a mess. And I think the big insight there was actually try to, okay, so yeah, I mean, that was sort of the gist of it. I think the other example I wanted to emphasize was the one where someone added a default value. So a new field, a new table with a default value, table with 5 billion rows, and basically that locks the table for writes because it has to write it for every row in this massive table. And so the recommendation in that case was avoid making it a required field. And don't add the default value. What you should do is you should slowly backfill it so you're not causing any blocks. And then once you're happy with the table, then you can add whatever constraint that you need, and it'll likely be much shorter.
Yeah, I mean, the thing with migrations, once data comes into play, is that it's really hard to pre-generate, for example, down migrations, right? Some operations fundamentally cannot be undone if you're not in a transaction, right? If you drop a column, your pre-generated down migration will recreate it, but your data is gone, right? If you write to null values, some value, right, and you want to undo that, you've lost the information usually where you overwrote nulls. So pre-generated migrations are not always the answer.
Okay, and what would you sort of say, I think we discussed this, and this is also in the blog post, but what are sort of your general high-level recommendations when it comes to schema migrations?
Yeah, I think going in small steps is always good. Do not try to do everything at once. It's easier to review for colleagues. It's easier to revert, and the separate migrations will apply faster. So I think that would be a general recommendation. And then, of course, there are a lot of patterns that you can use. I'm not sure. I think we also have resources about the expand and contract pattern that you use to migrations non-breaking, and but we hope to make the easy parts a lot easier for you. But in some cases, there is still manual work needed.
And we had a question from Ruben who asked, can migrations be created without schema changes? For example, if I wanted to add Postgres partitions which are not supported by Prisma, but still want them to be added via Prisma migration system.
Yeah, so what you can do is Prisma creates migration files, which are SQL files, which are then applied by Prisma. So you can modify those. So if you locally create a migration with Prisma migrate dev / create only, then you get a migration file that you can modify before it gets applied. And in there, you can do anything that you can do in SQL. The caveat here is that diff will not be aware of your handwritten SQL. At least not on the data model level, right? Because it's not represented there. It will be aware if it's in your migrations history. So if you take the from or to as a migrations history, and that contains your custom SQL, then that will be run again and will be part of the comparison. But if you take a data model where you currently cannot express some things, then Prisma does not know about it.
Okay, Ruben, I hope that answers your question. And we also had a nice comment from Andreas Straub, who mentioned that they've been using Prisma for a year now and 4 months in production. And great to hear that it's working good and that migrations are awesome. So really, we want you to try this out. If you have been using Prisma Migrate, check out these new commands. And Matthias, do you want to leave any other information with our audience?
Yeah, I would recommend to just check out Daniel's blog post, and just seeing, as we said, seeing the visuals really helps drive the finer points of the from and to, and which directions and environments you can pick on, really drives that home.
Cool. Thank you so much for joining, Matthias, and we hope to have you here soon, either when it's generally available or when we have other cool stuff that you've worked on.
Yeah, thanks for having me.
Ciao, ciao.
Matthias.
Bye.
All right. Moving on, we have another special guest. Let's get the names right. Yes.
Oh.
Okay. Oh.
No, sorry, it was me. You want to go? Okay, yeah, you just go.
Oh, yeah, sorry. Yeah. Oh, should we just invite our next guest for today?
Yes.
Okay, so our next guest is someone special, and his name is Aydrian. He's from CockroachDB, and he's from the he's a developer advocate at CockroachDB, and he's a Hoosier, which means a native of Indiana, living in the big city. He enjoys mentoring at hackathons and live coding on Twitch. Aydrian began his career helping bring technology to schools by setting up computer labs and training teachers and staff. So with that, let's have Aydrian join us. Hey, Aydrian.
Hey, howdy.
All right, let's try to get this up. Yes, and we're almost there. Okay. Thanks for joining us today, Aydrian. And we're here to talk about this great preview release of the CockroachDB Connector.
Yes, I'm very excited about this. During my interviews for this position, one of the first things I asked is, will we have full access to Prisma? Because around that time, Prisma was really starting to get a lot of chatter in the community, and it was like the first thing I wanted to try. And we did run into some problems, so I'm glad that we have our own connector coming out. But I've been working with it for a while using the Postgres connector, and now moving everything over to use the new one.
Nice. And we should also mention that you actually presented at our Prisma Serverless Data Conference that we held in November, where you gave a talk, and internally you also won the title of the best talk of that conference, because it was called Serverless Code More. No, what was it?
Yeah.
Which way around?
Serverless Code More.
Serverless Code More. Yeah, I could have wore that T-shirt today, but I chose the just regular logo.
Great title, and we'll drop the link to that talk also in the comments so that folks have a chance to check it out afterwards.
Great. So today you're going to be giving us a bit of a demo, and then we're going to do maybe a Q&A following that.
Sure.
Do you want to get right into the demo, or would you prefer to maybe give a bit of a background about CockroachDB?
Yeah. So CockroachDB is it's fairly new. I think we just celebrated the anniversary of the first commit to CockroachDB that was made by our CEO Spencer about, I think it was 7 years ago. So the company's been around for 6, but the product has been around a year longer. So CockroachDB is a cloud native distributed database. Hi. Sorry. As you can see, I've got Atticus back here.
Atticus in the house.
But like a cockroach, we can survive anything, thrive anywhere, and scale rapidly. So we're built from the ground up to be distributed. We do support the Postgres wire protocol, so that gives a lot of great like familiarity for developers. I think last time I checked, we were about 90% compatible with Postgres 13. So that gives us the ability to work without special integrations for a lot of database tool providers. So you can pick your favorite client, which mine happens to be Prisma now. But if you wanted to use Node PG or any kind of Postgres client, you can interact with it. And we're getting more compatible with every release. Yeah. But also, we just recently came out with our serverless. So we have elastic scale, so we can grow with you and scale back down when you're not using it.
Nice. So this is really where, from what I understand, Cockroach is really unique in that it can scale horizontally very easily, especially in comparison to Postgres, where you might have this sort of master-slave kind of like a read replicas, and if you want to have master, then it's super complicated. You have to use all of these special technologies, and with Cockroach, all of this is baked into the database itself, right?
Yeah, absolutely. We're not actually running Postgres like behind the scenes. So from a developer's perspective, it looks like Postgres, but we were built from the ground up to be distributed. So it's not Postgres at all. We're just implementing the wire protocol, and we have built it to where you can be horizontally scaling. Like I said, it was built with the cloud in mind. Yeah, it just works, as my colleague Rain just said.
Great. So should we dive into some code?
Sure. I guess I should share my screen.
Yeah.
Okay.
And this is also a good moment to say that for the Cockroach serverless, there's a very generous free tier, so you can try it out quite easily.
Yes. I believe it's, well, I just forgot all of what's available in the free tier, but it is very generous. And the cool thing is when you're not using it, you're not paying for it. So you can set a max spending limit to 0, and you'll never exit that free tier. But as you grow, we can grow with you, and you can increase how much you're willing to spend every month on your database. And the good thing is, if you don't reach that, if you never pass this free tier, you don't get billed. So that's been really nice. There we go, 5 gigabytes free and 250 million request units per month.
Nice.
So
and
I've been building a lot of things, and they haven't charged me yet, which is really good.
When I've tested,
I don't even have a credit card hooked up to my account.
To create multiple databases, I saw, on a single serverless instance, which is also a nice thing.
Yes. So I have a few clusters. So with this CockroachDB serverless, you can sign up and create a number of clusters, and then each cluster can have multiple databases on there. So I usually work between 2 clusters because I have one that's hosted on AWS, and then I have one that's hosted on Google Cloud Platform. And so depending on what I'm doing, I'll pick the appropriate cluster. But the other thing I wanted to mention, I just thought about it. It's really hard hearing myself back into the monitors. So it's affecting my train of thought. But with our nodes, every node that we have with CockroachDB can be read or write. So that's something I think that's also pretty great with the scaling. And then I wanted to mention that we can also region lock your data, so we can make sure that the data is as close to the user as possible. And with all of the Jamstack things coming out, like making sure all of your content is on the edge, we're working towards making sure all your data is available on the edge too. So that way the person who's sitting in Sydney, Australia can have the same experience as the person sitting in Manhattan. So the demo I have is kind of small. I mainly wanted to talk through what's available in this preview and kind of the flow that you want to go through to be successful working with this preview. So what we are working on, we're big fans of hackathons. That's pretty much how I got my start in developer relations, working at hackathons. But what we want to do is we want to put out these different starters. So, people in hackathons, people doing side projects, or really anybody who wants to kind of see how code is interactive can quickly get started using CockroachDB with Prisma, and then all these other things. So on my stream on Tuesday, I started working on this Next.js starter. So this is an application. So if you wanted to create a new application, you wanted to use Next.js, you wanted to use NextAuth with it, you can get started by going to the repo. This is going to be prettier over time, but you can just deploy it to Netlify. This is the first one that we're doing. Going to come up with a Vercel button as well. So that way you can choose where you want it to be hosted. But this will get you started using Prisma, using CockroachDB, and getting auth set up. And so I thought this was a good way to kind of show off what you need to have set up to use with Prisma, because we need to have a model set up that has the users table, the accounts table, the sessions table, etc. But then I can show you kind of how we can get that started using CockroachDB. Cool. So right off the bat, you have your Prisma folder that's going to have your Prisma schema. And so here is the schema. This is mostly given to you if you look in the documentation of NextAuth. So here are the models that it needs. But up here in the provider, we are using the CockroachDB preview feature, which allows us to use CockroachDB provider. So this is all set up. This is given to you, but in the current state of the preview release, you're not able to use Prisma Migrate, the wonderful thing that you were just talking about earlier. So what I have done is I have given you the code. So here's an init database script. Because what we would normally do using this preview is we would start with a database. So you need to have an existing database with all the tables that you need. And then you can easily create the model using npx Prisma DB pool. And so that would introspect the database, pull out all the information, and stick it into the model. And then from there, you can use npx Prisma generate to generate your client. For all of the applications that I've been writing with Prisma, I have been including this init database script just to help you out. So we want to make it as easy as possible for developers to quickly get up and running with applications. And so you might not know SQL. And so we want to help you out there, because the great thing about Prisma is people who, have no history of writing SQL code, dealing with databases can quickly get up and going with that. So we've provided this. And so for current CockroachDB users or people who are comfortable building out databases using create tables, create database, understanding what it needs to put in the different constraints, you're kind of off to the races. For everyone else, there's a nice little CockroachDB shell tool that you can do to load this directly into your database and get it created. One thing that I think is really cool, and using Prisma has kind of helped me understand database constraints a little better, because you have the find unique command, and you need a key to be able to use that. Like the where will only take something that's a key. And what I learned is if you have a unique key, so right here, we have a unique key set up for provider and account ID. You can use that compound key inside of that where clause. And so I think by default, it would be like provider underscore account underscore ID. And then you can pass in those two values, and then you can just get it. So I thought that was really cool. And I talk about that a lot. Anybody who will listen to me using those unique keys. So that's pretty much all the setup that you need. And if I could just go back to the README real quickly, we can talk about, sorry, it's right here. You can set up your free serverless cluster, and then here's how you would execute that script. So it's really simple shell.
One quick question, only to like reiterate, I think what you like said, Aydrian. So you said that Prisma Migrate is not yet available for the CockroachDB like supported connector, right? But if people have an existing CockroachDB database, then they can use Prisma's introspection, the PrismaDB pull command, to run against the database, and that way generate their Prisma models. Is that right?
Yes.
Okay, perfect.
And then what I find myself doing after I do a DB pull, I didn't have to do it here because these models were given to me by NextAuth, but I like to go in and clean up the models. So all of my tables in CockroachDB are lowercase. I use snake case with the underscores. So I like to go back into the model after I do the DB pull and use the @map or the @map. So that way I can make the model names capitalized and singular, and then I can make the fields camel case, so it feels a little more JavaScripty.
Nice.
You don't
and we have an open issue. And we do have an open issue to hopefully at some point make that automatic so that you don't have to do that manually anymore, and that you can convert automatically from snake case in the database to camel case in the Prisma client. A lot of people have been asking for that just because it's kind of a convention to use snake case in databases. And it's kind of tedious if you have a large database schema and then you have to map every field and every table. That can become quite a bit of work. So hopefully that's going to be available soon.
Oh yeah, we can't wait to amplify that tweet whenever it comes out. But just real quickly, I'll go through kind of how blazingly fast it is to create a cluster. So I'm going to log into mine real quick. Did I not spell it right? Okay. We'll just hit the button. Try to be cool and just type in the URL. I'll hit the sign in button. So here we go.
Everybody politely look away.
Oh, it's okay. It's just one password. I don't even think it shows it. You know, the secrets that I have shown on my stream, it just doesn't even faze me anymore. I have all of my stuff set up to where if I show a secret, I can easily like change it. Yeah, it just doesn't even faze me anymore. So you can see I've got a few clusters here. You can sign in. Again, it's not going to ask you for a credit card. Signing up is really fast. But let's create a new cluster. Let's create one that we'll use. We're going to do a serverless one. You can change your provider. So if you are using Google Cloud or AWS, you can make that selection.
Sweet.
You can pick the region. So I think we just recently added some regions. But we have Europe West 1, Asia Southeast 1, US West 2, US Central 1. I'm going to pick Iowa because I'm from the Midwest. So we'll deploy it to there. The spin limit, as I talked about, if you set it to 0, then you're going to be locked to the free tier. So once you get outside of kind of that free allowance that we give you, it throttles. But as you grow, you can up that, and then you'll still consume the free tier allowance. But then anything outside of the free tier, you'll start getting charged for. So I'm going to keep that at 0. And then the cluster name, you can choose their cluster name. So it comes up with just like an adjective animal. You can name it whatever you want. I know Rain likes to use Sparkle Kitten. I have one called Courteous Corgi, of course. But we'll just use Flashy Phantom, one with weird alliteration. And then we'll just create. And so we're creating the cluster, 5 to 10 seconds. And we're done. How fast can you do it? My fans on my laptop are just like going off. So I'm surprised it was working that fast. But we are ready to go. And with the new integration, the great thing is this connection string, you can just grab it and use it. So when I was using the PostgreSQL connector, I would have to take the connection string and like change things around. But as part of this connector, it's using things like this option, which is what we use to pass your cluster ID because this is multi-tenant. So yeah, that's it.
Very, very nice. And so that starter is available. Like maybe we can also share the link to that in the comments as well.
Yeah, it's still considered a work in progress because I just started it on Tuesday, but we're going to get that out. And then my next one that I want to do is using Remix because that's very cool.
Nice.
We're actually hosting next week, I believe it is, this Prisma Meetup Remix edition. So if we do another round of that, we should definitely have you come and join it.
Yeah, it seems like Remix has gotten like quite a bit of, or that like Prisma has gotten quite a bit of love in the Remix community and is kind of like being promoted as the default way to work with databases in Remix, even by folks like Kent and Ryan. So that's really nice to see.
One of their tutorials just says use Prisma. So like whenever I was going through how to use database with Remix, it was like use Prisma, and I was like, oh great, I got this. But yeah, so I have a sample app coming out. I wanted to demo it, but we're not quite ready with it. But it's coming out in time for the Super Bowl, Superb Owl, whatever gets us through. But it was written using Remix and Prisma, and it's gonna be a lot of fun. It's gonna be our take on the Super Bowl squares game that people play during the Super Bowl.
Sweet.
Yeah.
And Paul Kernfeld, he gave us a tip for the Remix meetup where he was like, I'd love to hear from the panelists. What kind of projects might you use Remix for and why?
So for me personally, I have to say I am not a front-end developer and I don't know too much about the differences between Next and Remix. So I'm not going to share an opinion about this. But like maybe other folks have, and otherwise I would recommend to tune into the meetup that we're hosting next week. Maybe they'll elaborate on that a little bit more there.
Yeah.
We'll leave it to the experts, but there's a lot of really cool things where like it will fall back without JavaScript. But like you can basically use it for anything that you build an application for. Like it's not just for websites, it can be web apps.
All right. Is there anything else that you want to share with our viewers, Aydrian?
I don't think so. We'll drop the link to our community Slack. If you are using CockroachDB with Prisma and you have any questions, you can always join us in our community Slack. Our engineers are in there. I'm in there. And then you can also find out like when our engineers are streaming because we have a nice little bot that will alert you in that channel.
Very, very cool. Then thank you so much for joining us today. And yeah, we'll certainly see you around in our community, Aydrian. Really looking forward to the upcoming app that you're building.
Yep.
All right. Bye-bye.
Bye.
Cheers.
Ciao.
All right. Moving on. We have one more guest that we're interviewing today. And this guest, or what he has to show us, is not related to anything that we released on Tuesday, unlike what Matthias and Aydrian have showed us. But we have been in touch for quite a while already, and I'm excited that he's joining us today. So here is Alex.
Hello.
Hello.
Hey, Alex.
How you
nice
doing?
to have you on the stream. Doing
Very
really well
appreciate it.
over here.
That was a super cool demo.
We actually have an interesting history, Alex. I just remembered actually that we met on Twitter initially, where I had reached out to you because I saw that you wrote a blog post about end-to-end type safety, where you used TypeORM and TypeGraphQL on the back end. And I was just curious. I mean, I do this like every once in a while when I see people that are using other database libraries, and I'm just kind of genuinely interested what kind of factors are driving their decision for that particular library. So I reached out to you, we kicked off a conversation, and I think you mentioned that you hadn't really been aware of Prisma. Then you started looking into it, and I think you liked it.
Yeah, absolutely. That particular blog post was me just kind of figuring out a way to get end-to-end type safety all the way from the database through a node server, GraphQL, down to a client that for an app I was building at the time. And this was a few years ago now, actually. So you really dig back through Twitter. GraphQL was great at the time. The app was actually in Flutter. And TypeScript, it was my first kind of project to learn TypeScript, and TypeOM was the one that everyone was talking about at the time, which I liked. You could sort of define the types, and there was all annotations and that sort of thing. And then this name Prisma kept appearing, and it rung a few bells because I remember GraphQL from back in the day, which I know is a way back. And then there was like the Prisma GraphQL thing, and then Prisma 2, and the way that Prisma approaches it with this sort of standalone model and being able to then point it at essentially any database connection, and the way you're going with the data platform as well, it just made a lot of sense to me. And being able to like define this kind of like business logic or the data model or policies as a configuration file that's standalone from your app code just made a ton of sense to me. And then the tool chain was so nice around it, being able to push pull, like do all the migration work, all the stuff you don't want to think about. Like, I know I need a database. I've got a database. I don't care about how it runs. I know what the API looks like. Just plug it in and go. I want to focus on building my business logic. Is kind of exactly why I love Prisma and the community. And yeah, I love everything you guys are doing, really. And it's my go-to ORM these days.
Nice. That's great to hear. But we didn't bring you on to talk about GraphQL and end-to-end type safety, because since then, I believe you switched roles and you're now working at a company called Cerbos. Maybe quickly introduce what Cerbos is and what you do there.
Yeah, absolutely. So I'm the product lead at Cerbos. We're a recently funded startup. We are building a modern open source IAM service to make sure no one ever has to reinvent permissions. So kind of what does that mean if we unpack it? Through the experience of our team, we've got Google, Microsoft, Elastic, and my own experience, both as an engineer and a product manager more recently in mainly B2B SaaS companies. You spend a lot of time building these bits of infrastructure that you don't really want to build or manage or maintain because it's not core to your business. And you don't build a database, you just pick one off the shelf and plug it in. And user permissions is one that I personally have had to rebuild in different roles over the years 3 or 4 times to work out who's allowed to access what and what actions they're allowed to do. And these things aren't simple projects, particularly once you get kind of more into the enterprisey world where you have customers that have different organizational structures and you have quite complex resources and actions. These things are quite hard to build, and they're quite bespoke at the time. On average, when I've done these over the years, it's taken 3-4 months of a squad of 6 engineers to go and build this and integrate it across the stack. And that's just time wasted that isn't core, and you're not building the value for your end customer. So we decided to go and solve it once and for all, and build a access management service that is open source. You can pick it off the shelf, plug it into your stack, and off you go. And one of the first integrations we built has been for Prisma, and that's kind of what we want to talk about today.
Nice. Yeah. And you recently shared a quick video with me that I also shared internally, and everybody was really excited about it. And following that video, I thought it would also be nice to share that with our community. That's why we invited you on today. So if you want to go ahead and share your stream and also give kind of a more practical introduction to Cerbos again and explain how it plays together with Prisma, I think that would be great now.
Yeah, absolutely. So if we kind of start off with kind of typically how you'd build an app today that has access controls in there. At some point in your code, there will be a if statement or a check or a where clause on your SQL query to work out whether a user is allowed to do a particular action. So let's say you had like a CRM system with some contacts in it, and you want to figure out whether a user is allowed to update or delete or edit or publish or modify a contact that's inside of that system some way. That is logic which at some point came from some business requirements, and a product manager landed a Jira ticket in your queue, or and you signed a new customer as this new custom requirement for how you want to give access to the system. That logic needs to be converted into code traditionally and then put into your app. And if you have a small monolithic application, that's fine. But as soon as you start sort of scaling up and you have lots of actions and lots of resource types that are interacting with each other, it gets quite complicated. And this factor is multiplied 10x as soon as you have multiple microservices, let's say, that are in different languages and have to replicate that same logic. So now every change request that comes through for a new permission type, requires you to go into touch the code base for every service, which may be a different language, and update and convert that business logic to enforce those permissions and enforce those checks and all the pains it needs to be. As requirements change, they always do. That's the nature of the beast, especially as you're moving fast. So the aim of Cerbos is we were replacing all that complicated logic which exists in your code with a central service, and that central service provides a way to define these authorization policies, which we'll go through in a second, as easy human readable configuration files, much like a Prisma model, which extracts it out of your sort of core code base and offers a simple API. So your code no longer is going, okay, get this resource, check whether a user is the owner of it, check whether they last published it, check if it's in a group they belong to, etc. Now there's a single call out to the Cerbos service, which you're running somewhere in your stack. If you like Kubernetes as a sidecar, or if you're running on like a VM, you can run it anywhere. You just say to Cerbos saying, right, I've got this user. They're trying to access this particular contact, let's say, and they're trying to update it. Cerbos will then go through all the policies and figure out, yes, no, is this person allowed to do it, and simply return a allow or deny back to your app, and now your code path can continue and off you go. So now all that business logic, all that authorization logic has now been offloaded to these configuration files, these policy files, which actually, if you're a developer, you can now hand off to like a product manager or a security team member to actually manage themselves directly. And those policies can evolve over time, and you no longer have to go and update your code base and update your application every time the business logic changes for around who can do what. That's all just done in these configuration files. And that single integration you've done is a set and forget type coding integration to go and check the updates. And the advantage is you now have this one place to update policies, and if you're in a regulated industry, you now have this audit trail ability that's very easy to go and fetch every single action that occurs and pipe that into your log system or whatever system you're using. So in terms of where Prisma fits in with all this, is Cerbos is sort of a core which connects to different parts of your stack. The first place it needs to talk to is your authentication system. So you might be using Auth0, you might be using Google login, you might be using GitHub login or your own username password. You can bring your identity from anywhere, and that's the first step, which is knows who is this person. The second thing it will connect into is your directory information. So if you're a kind of a larger SaaS application, or you're working with like an enterprise system, you might have Active Directory, you might have Okta or Google Workspaces, and there's kind of these directory services which contain the information about, okay, what role has this person got, or what group are they in, or what department are they in inside of the business. And this information can then be consumed by Cerbos to then make the policy decisions around who's allowed to do what. So it knows, okay, I now know who this person is, I now know what roles or what department they're in, and they're trying to access this particular resource. And based on those policies, Cerbos can then decide yes or no, is this going to be action to be allowed or not. And then the final piece is then Cerbos will then can connect into your data fetching layer, and this is where Prisma comes in, to actually go and take the user and the resource that they're trying to access and return back what we're calling a query plan, and actually push that down into your SQL query. And that way you can actually push authorization logic down into your data fetching layer through Prisma or whatever you're using to really optimize and solve what we call the listing problem. And that's the bit that I'm going to jump into my screen share and walk you through how it all works.
That sounds really, really useful. I'm really excited to see this live now.
Yeah. Okay. So I'm going to do a bit of scene setting just to walk you through kind of our demo app, and then we'll jump into the code. So a query plan, if you're used to SQL, it doesn't look like SQL, but if you understand Boolean logic, you can kind of read through this and understand what's going on. So Cerbos, you give it a user and you give it the resource type they're trying to fetch, and we have a dummy CRM application, and then it returns back the conditions which need to be pushed down into essentially your where clause on your data fetching layer to go and bring back just the resources that a user is actually allowed to access based on your policies. And it's smart. So there's a lot of work going on under the hood to work out what the minimal number of conditions are required to apply to the query to fetch what that user is allowed to access. So for two different users, for example, a regular user versus a manager, you would actually get a different response back based on what conditions need to be applied, because a manager has more power, thus they can see more in the system, thus there's fewer things to be filtered out. So it's kind of like the more power you have, the less conditions you need to apply on the filter. And I've jumped it. And so what we've been developing, and Prisma is the first one we've done, is a series of adapters that convert this generic query plan into a syntax to go and do the lookup. So we're aware in larger systems, you might have some data inside of database with Prisma on top. You might have some things cached in Redis. You might have some things in Firebase. It doesn't really matter. And this generic query plan can then be adapted to go and connect into any one of those solutions. And then Prisma is the first adapter that we are publishing. So a bit of a demo of how this works. So we have a demo app called Cerbos, which is a dummy CRM application that we use for examples. And this is kind of a good one because you have lots of different user types and user roles that exist in these kind of systems. You have someone like creating contact, you might have a marketing team sending newsletters, you might have leads coming in from a website, and there's lots of different user interactions that occur there. And in this kind of example one, we have a user who's either an admin or a regular user coming from that authentication provider. We have a department, whether they're in IT or sales or marketing, which is coming from the directory information. And then the resource that we're going to look at in this example is a contact. And there's kind of a contact has some attributes about it, and it belongs to the user that created it. So the owner ID attribute in your sort of Prisma model is the ID of the user that created it. Is either active or inactive, and then there's a flag that says whether they've opted in for marketing. So can we send this person a newsletter, for example? And so the business requirements have been mapped into a Cerbos policy. And we have a live sort of interactive playground where you can actually go and play around with creating policies. And the business requirements for this particular for this particular resource type, which is a contact, is admins are allowed to do everything. So we have this kind of syntax. Hopefully, even without looking at the documentation, you'll be able to understand kind of what this policy does. But a contact is allowed to do everything. An admin is allowed to do everything. A user is allowed to create when this condition is true. And so we're saying a user is allowed to create a contact if the department of that principal, as we call it, is set to sales. And then an owner of a contact, and this is an example where we're doing request time checks, contextual checks to make sure whether the user is an owner of a resource. So this is something called attribute-based access control. You might have held a role-based access control, but this is the next level of detail to use that context. So we're saying you're allowed to read and update or delete a contact if you're an owner. And if a reading is a kind of a more complex example, you'll see how this maps to a Prisma call in a second, where we're saying a user is allowed to read it, firstly, if the contact is true, and then either they are in sales or they are in marketing and the marketing opt-in flag has been set to true. So this is like that business logic that has been somewhat, it's been defined by some person inside of the company, be it a product manager or a security team or someone else, that needs to be kind of mapped into the system, and it's been defined in this central Cerbos policy, which then can be checked from anywhere inside of the application, be it front end, back end, some part of the service. You just hit Cerbos with right, I've got this user, I've got this resource, can they do this thing? It comes back yes or no. There's a quick link to the playground if you want to go and play with that. So what does this actually look like in our code? So we have our Prisma model. We have a contact which has those attributes that I was kind of talking about. So it has an owner, and that's a relationship to the user object. It has these Boolean flags for whether the contact is active or opted in for marketing. And a user has a department also.
One quick question, actually, Alex.
Sure.
So when I looked at that demo before, I was wondering, how is the Prisma model contact mapped to the resource that is listed in your service config? Is that just by name and basically case insensitive? Because in the Prisma model, it's spelled with an uppercase C, and in the service config with a lowercase c?
Yeah, I can show you how that works right now. So we have a handler here for going to fetch all the contacts. And the listing, the listing problem that is a problem in any sort of authorization system is if you have a single resource and you want to see whether someone can do something on it, it's quite easy. You have the resource, you have the user, you go and say, can they do this thing? And it comes back yes or no. But if you wanted to present a list of contacts, so like an index page, and you have like, your 100 contacts in the system, the kind of dumb way to do it, or the way you'd be forced to do it normally, is you have to go and fetch all the contacts in the system and then iterate through each one to say, right, can this user view it or edit it or delete it? And then essentially filter that list, which could be tens, hundreds, thousands, millions of contacts in your system, filter it down and then return the ones that the user is authorized to, which is very inefficient because you might have 1 million contacts in the system, but your user can only access 10 of them or 5 of them or none of them in some cases. So you're putting all this extra load to fetch everything out of the database. You're pushing a load of data through, and that's just not going to scale. So with the query plan, as I said, as I was kind of describing earlier, we're pushing that predicate logic down into the data layer and the authorization logic down into the data fetching layer through applying a where clause on that query. But we're applying a where clause not by manually writing the where clause into our code base and thus have to go and change it and update it every single time the requirements change. We're generating the where clause at request time using the context of the request from the policies that are live inside of your Cerbos environment. So what this actually looks like in code, if we're going to go and get contacts, rather than directly just calling Prisma contacts find many and just return everything, we're first going to construct that query plan. So we have a Node SDK, and we also have them for Go and Java and Python and Ruby coming soon. We have the Cerbos library, and you say, right, go and get me the query plan. And go and get me the query plan for this user. And here we're passing in the principal information, so the user's ID, what role they have, attributes about the user, in this case, the department. And we're saying this user is trying to read all the contact resources. So this is where the kind of mapping occurs between the Prisma model and your policies. Right. It's a string match right now. There's nothing smarter than that. But this is referencing the resources that are indexed or available in your Cerbos policies, and then the action we're trying to do is read. So that then goes off, and because this Cerbos is deployed alongside your application, it's a super fast. We're a Go house rather than Rust, I'm afraid. Core, but it's super snappy, and you get results back in sub-millisecond. That then comes back, and we have this abstract query tree. Abstract syntax tree back in the application, and then we're releasing these adapters, and the query plan to Prisma method you see here is that first one. So we give it firstly the query plan itself, and then we just need to provide a mapper which says, okay, in the policy the field called owner ID maps to the owner ID field inside of the Prisma model, and you just need to pass through basically what that mapping is, and then what comes out of that function is an object which is compatible with the Prisma where clause syntax, and then you simply pass that in to your find many in this case as your where, and the filters that come back are the filters that should be applied based on the authorization logic. And you could wrap this in an and as well if you have other conditions you want to apply for like pagination and thing also. And then that goes off and actually runs the underlying query, and the results.
That's so cool.
So hopefully that makes sense, and I can kind of give you through a worked example of what's going on under the hood for how this works. So we have a few different users. We have Alice, who's an admin user. Her principal, her user object, states that she is a admin and she's in the IT department. The query plan that comes back from Cerbos says, okay, this person's an admin, they're allowed to do everything, so the response type is always allow, and thus the mapped where clause that goes inside your Pickle query doesn't contain anything because they're allowed to see everything. So that's a simple example. We have Sarah, who's a sales user. So her role is user now, so not admin. Her department is sales. And then we have the query plan that comes back and says, okay, this time we have some conditions. So to fetch just the contacts that Sarah is allowed to access, we need to check that the owner ID is equal to her user ID. So this is where we're actually pre-computing as many of the conditions as we can. Or the resource attribute active has to be true. And that gets mapped into the Prisma where clause that looks like this. So again, this is all being generated on the fly. There's no writing these where clauses or hard coding this logic anywhere. It's coming back based on what the current live policies were. So if the policies were to change because some business requirements changed, this would be generated with a different set of conditions, and thus you would get a different result set based on the new authorization logic. John is a similar user, but a slightly different user ID. Thus, the query plan is slightly different. Thus, the where clause now has to look for a different value, but that result then comes back. And then final, more complex example is with Jerry, who's in the marketing department, and our business requirements for marketing were the content had to be active and opted in for marketing before our marketing users could access it. So the resulting query now is got a different set of conditions. So we're saying the owner ID has to equal Jerry's ID, or the active and marketing opt-in fields have to be true. And again, this is all generated on the fly.
Wow.
So what
That's
that
very cool.
maps to in our dummy application, which is all up on GitHub, every time we hit the API, so Alice can see Simon and Nick, but if we say, I'm actually Jerry, this is like faking a login, we're going to get back a different result set, which is again filtered based purely on the policies that are sitting inside of Cerbos, all centralized, version controlled, can be audited without you having to hard code any business logic into your application. And yeah, that's everything's going to show.
Very, very cool.
So Cerbos is open source, is that correct? And
Yep.
you mentioned you run this as a sidecar, and I assume that this needs to run as a process because you want to persist this into some kind of an audit log, and you want to be able to sort of interact with it as an API. Like, how does it work? If you have multiple services, do they each have a sidecar, or is it just a single one?
Yeah. So yeah, Cerbos is completely open source. It's up there on GitHub, Apache 2 license. The core is out there. We have many users out there in production using this today, controlling exercise in their application. And the reason why Cerbos is like a sidecar or a binary that you run in your stack, primarily is for speed. Unlike authentication, where you can go and like do a login with, say, Auth0, and you can cache that authentication for some period of time because your authentication state doesn't change. Authorization is very different. You're checking every request or every action that goes through. So you don't want to be round tripping over the internet necessarily. You want to be making sure this is quite snappy. So we distribute the binary. We distribute Cerbos as a container. So you can run that anywhere if you're running a Docker container, but equally you can run the binary. It's all up on our github.com/Cerbos. And that means you can call it very quickly from your application code. And for larger scale applications, we quite a lot of us have experience of running things that are doing 250,000 requests a second. You want to be able to scale up, and you want to keep latencies as low as possible. And sidecars is a kind of the modern approach to doing this that's been led by Google, Microsoft, Amazon. They're all kind of doing this approach to making sure that as you scale, your processes that require to keep that service running scale with it. And Cerbos itself is stateless. So once Cerbos boots up, it goes and fetches the policies from wherever you configured it. So be it a Git repo, if you're following GitOps type workflow, or an S3 bucket or a GCS bucket. We were just talking in our Slack saying, right, we need to go and build a CockroachDB connector for that as a place to persist policies. So that'll be on our list next.
Are relational databases supported as like a storage for
Yep.
policies?
Yeah, so like Postgres, MS SQL's just landed as well, MySQL. And then Cerbos engine itself kind of maintains the state of that. And we provide an admin API where you can actually dynamically update or push new policies into it, and they'll get written back to the database if you wanted to drive, say, a permissioning UI through Cerbos.
Okay. But the idea is that basically you have a sidecar for every process that needs it, and they only do reading, so you don't have a problem if they're all basically reading from the same source of truth.
Exactly. Yeah, because the policies themselves are distributed.
Very cool. Thank you so much for working with us through it. This was my first time really seeing Cerbos in action. So
yeah, super insightful. One more question actually from my side. I don't expect that there are major differences, but I just want to get it out of the way. So you showed now the example of a REST API. And I know that in general, authorization is a big topic also in the GraphQL community. Are there any specifics to be aware of when using Cerbos with GraphQL?
So great question. We actually have a demo repo of a GraphQL server using Cerbos. So Cerbos itself is completely agnostic for where it's being called. and the check's being run. So it could be inside a resolver. And actually, it's a really good example where you could start returning null for that particular field in the tree if the user's not authorized, and you can essentially short circuit a lot of the authorization logic. But equally, if you had like an event processing queue, when events come off the queue, you can still check authorization of that. It doesn't really matter where the checks have come from.
Very cool. All right.
Final question we had from the audience: is it possible to extend existing Cerbos policies definitions to specific use cases?
So Cerbos policies are kind of down to you to define. You can create as many policies as you want for every resource that's inside of your system. And a resource just basically has a name and then a list of actions that are possible to perform on that particular resource. So whatever your use case is, you would say, say if you have a news website, you might have an article resource, and that article resource might have the ability to read, edit, delete, update, publish, approve comment, moderate comment. That you can go and put whatever actions you want into that particular resource type, and then Cerbos, when it receives a request saying, right, is this user authorized to do this action or these actions on this resource, it knows where to go and look to go and resolve the policies.
All right, Alex, thank you so much. Any final words before we let you go?
No, I guess congratulations on hitting 20,000 stars in your repo. We're a long way off. We can only aspire to be there. But you can find more about Cerbos and everything we're doing at cerbos.dev. And we also have a community Slack, which myself and the rest of the team and all our engineers hang out in and answer all sorts of fun, challenging authorization questions around how we can implement them with Cerbos. And we're always looking for new, interesting ways of using the tech.
Very cool. All right, then enjoy the rest of your day. Ciao, Alex.
All right. Thanks, guys.
Bye.
Ciao.
All right. We are almost at the end of the stream now. The final announcement that I want to make is just that we changed our release cadence. If folks have carefully read our release notes, you saw the note about this already. So instead of releasing every 2 weeks, we are now going to release new Prisma features and new releases every 3 weeks. And that also changes the cadence of this stream. So the next What's New in Prisma is going to happen in 3 weeks instead of 2 weeks. And with that, thank you everybody for watching today. I hope you had a great time, and please enjoy the rest of your evening. Bye-bye.
Ciao, Niko.